Hi everyone, this is practice formative of chapter 3, question number 17. So we have to find the area of the shaded region that is bounded by two functions. So let's look at the diagram here. We have the curve and the straight line. So we want the shaded region between these two functions. Now, as you know, when we integrate any curve towards the x-axis or with respect to x, we're actually shading towards the x-axis. Okay, which means if I shade the curve, I will eventually get this one, the pink shaded region. Okay, I will get the pink shaded region. And if I shade if I integrate the straight line, if I integrate the straight line, I will get the area of the blue shaded side, which is the area of the triangle. So in order for us to get the gray shaded region, we have to take the curve minus the triangle. Okay, therefore, it's either we use the integration fully for this question, or we combine integration and then minus the area of the triangle using the formula to find the area of the triangle. So both ways should give us the same answer. So let's look at part A. But before that, we have to find out what is this. Now, this is where our curve intersects with the straight line. So at this point, the y1 equals to the y2. Okay, so we shall take y1 equals to y2, therefore x equals to 4x minus x squared. Let's rearrange. We have x squared minus 4x plus x equals to 0. So x squared minus 3x equals to 0. We factorize it. So x times x minus 3 equals to 0. Therefore, it's either x equals to 0 or x equals to 3. So which is true? The point of intersection, we got two. One is at the origin, so x equals to 0. Another one is here, x equals to 3. Therefore, when we integrate, we shall integrate from 0 to 3. Okay, the area of the shaded region will equivalent to integration of the curve. We shall take the upper function minus the lower function. Okay, take the big one minus the small one. So we are taking y2 minus y1 towards the x-axis. Therefore, our boundary definitely from the x-axis, so 0 to 3. So what is y2? y2 is 4x minus x squared. The y1 is x. So we combine it, 0 to 3 dx. Okay, so 3x minus x squared. Okay, towards the x-axis, and now we integrate towards the x, so we have 3x squared over 2 minus x cubed over 3, and put in the boundary from 0 to 3. So let's put the 3 in. So 3 times 3 squared, which is 9 over 2, minus 3 to the power of 3, which is 27 over 3. And then minus 0. Okay, 0 you sub in, 0 over 2 minus 0 over 2 is still 0. So over here, we can use the calculator and do the calculation for us. So we have 27 over 2, 27 over 2 minus 27 over 3, which is 9. So we got the answer, 4.5. Okay, 4.5 unit squared. Okay, this is where we use the integration fully. If we want to combine integration and the formula, we can also do that. So let me just show you. Or we integrate from 0 to 3 the curve. Okay, we have 4x minus x squared dx. And then we minus half times the base times height. Okay, the base is 3 and the height. Since y equals to x, so the height is also 3. 3. Okay, so for this part, let's integrate. We have 2x squared minus x cubed over 3 from 0 to 3, and then minus 9 over 2. Then we substitute the 3 in. 3 squared is 9. 9 times 2 is 18. Minus 3 cubed is 27 over 3. And then we substitute 0 in. We got 0. And then minus 9 over 2. So this one simplified, which is 9. So 18 minus 9 is 9. So 9 minus 9 over 2. So we got 4.5 as well. Okay? So both method is acceptable. Unless the questions say use the calculus method, then we have to use the integration fully. All right, now next, let's move on to part B. So for part B, we have the straight line now on top. The curve is at the bottom. Therefore, we always take the upper curve minus the lower curve. And then the point of intersection is here. That means we are integrating. Okay, we are integrating the graph below from 0 to this point of intersection. If I integrate y equals to 2x plus 1, I will get the pink shaded region because we get area under the graph. Okay, but I don't want the whole thing. Okay, so this shape is the trapezium, yeah? So we can use the area of trapezium minus the, when I shade the curve. So the area under the curve will be this part, the green shaded part. Okay, so we have the planning now. We take the upper curve, upper graph, minus the lower graph. But before that, let's find the point of intersection. So for part B, again, y1 equals to y2. Therefore, we have x squared minus x plus 1 equals to 2x plus 1. And bring everything to the same side. So x squared minus x minus 3x, minus x minus 2x, we have minus 3x, plus 1 minus 1, 0. And we factorize x minus 3 equals to 0. So the point of intersection is x equals to 0 or x equals to 3. I got here 3. So what is this? If I were to use the trapezium, I have to know all this value. Then it's not a wise choice, yeah? Then we use the integration fully. So the area of the shaded region, always remember, take the upper curve. The upper graph is 2x plus 1 minus, isn't it? We have to take away the green part so that we're left with the pink or the gray part. So we minus the second graph, which is x squared minus x plus 1. Okay, we have to minus the curve from the straight line, not the other way around, yeah? Towards the x-axis. Therefore, our boundary must be on the x-axis, 0 to 3. Okay, so let's open up the bracket first. We have 2x plus 1 minus x squared plus x minus 1. And combine 2x plus x, we have 3x. Plus 1 minus 1, cancel off the value. So we're left with this. So once we simplify the function, now we can integrate from 0 to 3. Okay, so we have 3x squared over 2 minus x cubed over 3. And that is from 0 to 3. Substitute the 3 in. 3 squared, 9. 9 times 3, 27. So 27 over 2 minus 3 cubed, 27. 27 divided by 3, 9. And then minus, when I substitute the 0 in, I got 0 at the back. So 27 over 2 minus 9, we can use the calculator to help us. So 27 over 2, and then minus 9. So we got 4.5. Okay, 4.5 as well. 4.5 square unit. So we found the answer for B. And next, let's find the solution for C. Okay, in order for us to find the C, we have to look at the shaded region. Now, the shaded region basically is consists of the part, okay, that is bounded by the straight line and this X value. All right, and these two parts we can actually add together. We add together, so this is the straight line part, the straight line region, and the graph below the area below the curve. So this one we have to add. Okay, the previous two questions we minus, this one we add. So for part C, the point of intersection can be found when the y1 equals to y2. Now this is not fully in y, so let's make sure it is y. So this side is x over 2. So call this y1, this is y2. So when y1 equals to y2, we have x over 2 equals to x squared minus 6x plus 9. Get rid of the fraction mode, so times 2 on both sides. So we will have 2x squared minus 12x plus 18 equals to x. Bring the x over, we have 2x squared minus 13x plus 18 equals to 0. So we have to factorize it. We have to factorize this part. How do I get 18? And yet the sum is 13. So to get 18, we have 1 and 18, 2 and 9. Yeah, just use 2 and 9. 2 and 9, whereby the 2 is here, 9 is here. Double check. All right, the inner pair is negative 9x. The outer pair is negative 4x. Same sign, we find the sum, it gives us the negative 13x. And negative 2 times negative 9, we got positive 18. All right, so this is the correct factorization. So now from here, we got x either equals to 9 over 2 or x equals to 2. Which is this? As you can see, if I continue to, continue the graph, continue the straight line, I will have two point of intersection. Therefore, 9 over 2 must be, 9 over 2 is actually 4.5. Therefore, this one must be the first x value. So this is 2 here. Okay, this is 2. And then what is this? Since we need to integrate the straight line, so the straight line is actually from 0 to 2. And next we have to integrate the curve. So the curve is from 2 to up to here. So what is this point? So we have to find this. This is on the x-axis. So at x-axis, y equals to 0. So let's substitute y equals to 0 into the curve. Therefore, x squared minus 6x plus 9 equals to 0. And when we factorize this one, we will have x minus 3 squared equals to 0. Therefore, x minus 3 equals to 0, x equals to 3. So this is 3 here. So the area of the shaded region, okay, we have to integrate 0 to 2 of the straight line, which is y equals to x over 2. So x over 2 with respect of x. And then plus integration of 2 to 3 of the curve. The curve is x squared minus 6x plus 9. And then with respect of x. So let's do this part. So we have x to the power of 2 over 4 from 0 to 2 plus x cubed over 3 minus 3x squared plus 9x from 2 to 3. Okay, so for this one, we have substitute the 2 in 4. 4 divided by 4 is 1. So 1 minus 0 is still 1. So the area of this part is actually 1. Okay. Next, substitute this part. We put the 3 in. 3 cubed divided by 3 minus 3 times 3 squared plus 9 times 3, 27, minus when we substitute the 2 in, so 2 to the power 3 is 8, and then minus 3 times 2 to the power 2, which is 4, and then minus plus 9 times 2, which is 18. So for this one, let's simplify it. So we have 1. This one, after we simplify, 9 minus 27 plus 27, and then minus 8 over 3 minus 12 plus 18. So this one we can cancel off. So we have, well, let's use the calculator to calculate that part for us. So 1 plus 9 is 10. 10 minus, in the bracket, we have 8 over 3 minus 12 plus 18. And then we close the bracket. Okay, 1 and 1 over 3. So that is the answer. 1 and 1 over 3 square unit. Okay, so we found the area for part C. All right, now let's look at part D. So for part D, to find the area under the graph, let's look at this graph. When we say under the graph, is it we have to go use the straight line to drop until we touch the x-axis. So is this part. If I integrate here, right, from this point, okay, up to 6, I will get this part. And therefore, we shall take the area of the rectangle plus the area under the under this graph, add together, then we get the area of the shaded region. But first, we have to find what is this x value at this point when y equals to 4. So we put into the equation 3 over x cubed plus 1 equals to 4. 3 over x cubed equals to 3. Therefore, x cubed equals to 1, x equals to 1. So this is 1. Therefore, the area of the shaded region will be, we take the area of the rectangle plus the area under the graph, which we have to integrate from 1 to 6 towards the x-axis. All right, and 3x to the power of negative 3 plus 1. Okay, so area of the rectangle will be the length times the width. The length is 4, the width is 1. And then let's integrate this part. We add 1 to the power and then divided by the new power and then plus x from 1 to 6. So over here we got 4. And then over here, let's rewrite. So negative 3 over 2 x to the power of 2 plus x. And then we put the 1 and 6 in. Okay, 4 plus, okay, over here we have negative 3 over 2 times 6 squared, 36 plus 6, then minus. Put the 1 in, negative 3 over 2, and then plus 1. Let's use the calculator to get the answer. Okay, so we have 4 plus bracket. So we have negative 3 over 2 times 36, so that is 72. And then plus 6. Okay, close bracket. And then minus negative 3 over 2, negative 3 over 2, plus 1. Close bracket. And find the value. So the answer is 10 and 11 over 24. 10 and 11 over 24 units squared. Okay, so that's it for question number 17.